Good morning, everyone, and thanks for joining. My name is Kyle Boyar, and I'm a field application scientist with Biorad Laboratories. I also serve as chair of the American Chemical Society's Cannabis Chemistry Subdivision. And today I'm going to be talking with you guys about mycotoxins in cannabis flower. And since the abstract submission process for this was some time ago, this work has actually evolved quite a bit as this topic is kind of ongoing and a lot of new discoveries in the area are being made. So we also have done some additional analysis. So you're going to get a little extra for free. We're also going to include cannabis concentrates in the mix. So with that, I'll go ahead and dive in. So mycotoxin testing in the US. So we currently test for 5 mycotoxins in most jurisdictions. And so the sum of the aflatoxins, B1, B2, G1, and G2 are typically what is looked at, and that's at an action level of 20 ppb. Similarly, we also look for ochratoxin A, same action level. It's going to be less than 20 ppb in order to achieve a passing result. And so some things to think about as we go through this talk. How are these analytes and limits chosen? And then why do we test for some mycotoxins and not for others? I think, based on a lot of the regulations in other industries, right, regulators and policymakers took their best stab at this, but as we'll see throughout the presentation, I think that we might be looking in the wrong places. So the cannabis microbiome, let's kind of take a look at what is there initially, right? What is actually endogenously present within the cannabis microbiome to kind of look to where we should potentially be looking. And this is work from Kimberly Gwynn, who's sitting here in the audience, Max Leung, Samir Punja, Ariel Stevens. And this kind of takes an examination at, again, what is present within that microbiome and what is the potential for mycotoxin production from some of these different fungi. And so you'll notice I've highlighted 3 different areas here. So that's Aspergillus, Penicillium, and Fusarium. And really, these are the ones I would say that, based on this, right, you can see where the pluses are. Let's see if I got my pointer here. So you can see the different pluses here, and that indicates mycotoxin production potential. And so that mycotoxin production potential is kind of where I think we should be kind of zooming in and looking more closely. So you'll notice for things like Fusarium in particular, Sporotrichoides, as well as Fusarium graminearum, those are going to be major potential toxin producers within cannabis. So we want to kind of zoom in on that. And these different fungi within the cannabis microbiome can cause different types of mycoses. And of course, as I mentioned, they can also produce these mycotoxins. So I've got some examples of each of these below. Mucor on the right there, that's not included as much in terms of the mycotoxin production simply because it doesn't have as many pluses there in that previous graph. But again, a lot of these can cause different types of fungal infections in the lungs. So they are of concern and something that we should be considering testing for. Of course, we test for the 4 species of Aspergillus, but again, there are other considerations as well for some of these. For example, mucor has been associated with mucormycosis in some cannabis users. And so if we also zoom in on some of these, right, so these are the mycotoxins that can be produced by Aspergillus. So there's a numerous amount of health issues associated with these, which is, of course, why we test for them. So, mutagenic, nephrotoxic, ion channel perturbation in the case of aflatoxins, and then ochratoxin A, which there's a bit of crossover, which I'll go into in a minute, but carcinogenic, tumorigenic, it can result in kidney damage. So again, all things that you really don't want to have in your cannabis, and this can occur at low levels. So that's why we have the limits that we do. Now, if we move to Penicillium, I'm sorry, just to go back here a bit, you can also see, right, that that there's a bit of overlap where there's these trichothecenes, or trichothecenes, depending on how you want to pronounce it, that kind of overlaps as well. And those are going to be important because you'll see in some future slides that there is a kind of a crossover between some of these. Similarly, there is crossover with Penicillium. So this one also produces ochratoxin A, but it also has its own host of different mycotoxins to be considered depending on what species we're talking about. So in the context of things like Penicillium citrinum, this produces citrinin. This might be of concern for epileptic patients because of that ion channel perturbation. If you're taking something like, say, a CBD to control your epilepsy, and there's a bunch of citrinin in it, well, you might be modulating in a way that is not beneficial, especially because epilepsy is one of those things where you really have to dial things in. And this one is regulated by the FDA. Similarly, 20 ppb seems to be a common recurring theme in terms of action level. Paxilline is another one where that might be of consideration for epilepsy because, again, tremorigenic, ion channel perturbation as well, but there are no limits for this one. Potulin. Potulin is something that you commonly find in things like apple juice, and so it's a concern there. But again, to what extent it's of a concern in cannabis, it's not entirely clear. And this one is also regulated by the FDA at an action level of 20 ppb. Now, if we move to the Fusarium-derived mycotoxins, as you can see, there's a wide variety of these. And again, as you saw in the previous slide, some of these have a greater propensity to produce mycotoxins more than others. Again, that graminearum, that Sporotrichoides, these are kind of like the primary drivers. But as you can see, there's a wide array of these that are of concern, and I'm going to zoom in on some of these in just a bit. So we also got to consider what are some of the factors within the factors contributing to the production of mycotoxins in their presence. So firstly, the temperature, right, of course, is going to be important. Water activity within the cannabis sample is going to be important because if there's water activity is not within a certain range, then you may end up with the propensity for microbes to continue to grow and potentially produce mycotoxins. Similarly, relative humidity, where the cannabis is cultivated, where it's stored, that's also going to play a factor in mold growth. And then the pH as well, typically a pH around 4 to 5 is going to result in higher production. So a little more acidic can result in higher production of these compounds. And then the substrate. I think we also have to consider, obviously, cannabis has a lot of antimicrobial components with it. You got cannabinoids, terpenes, flavonoids. All of these things might inhibit the production of these various mycotoxins. Then another thing I think we need to consider is this derived from cannabis or hemp? So obviously I know they're the same thing. They're all cannabis sativa L, right? But we have this legal distinction, and we have different marketplaces that kind of sort of treat these things differently. So when I consider cannabis production, I think that there's a bit more care taken within that, because obviously, especially for connoisseurs, people are going to end up smoking this flower product. Whereas with hemp, a lot of this is just biomass that is being produced, ultimately to extract CBD out, to use in other downstream applications, things like conversion chemistry or CBD isolate products. And so again, they're treated differently in terms of how they're cultivated and produced. One is done with a bit more care, I would say. The other one is mass produced, bucket, chuck it, use it put it in your reactor and go, in your extraction vessels. So there's that. And then also we got to consider, is this product concentrated or not? And we're going to get into some of the data here in just a bit, kind of looking at flowers versus concentrates in this context. So if we look at the mycotoxin detection and failure rates across 10 US states in flower, so you'll notice this is over 400,000 data points. So, and this was procured by Yasha Khan. Kudos to him for this. So I want to point out some things. So you'll notice that our failure rate out of those over 400,000 samples is quite low. It is 0.01%. So not very common that you see these things failing, 59 of them total. And then if we look further down, we break this down by analyte specifically. And so you'll notice here that percent detected is mostly ochratoxin in this case, and percent failed again is mostly ochratoxin. And again, this is looking at over 400,000 samples for each of these. You'll notice also that the numbers don't add up. And the reason for that is some of these, in terms of the reporting, this all comes from metric and from FOIA requests. So sometimes the actual data that is being input looks at total mycotoxins. It doesn't actually look at individual analytes. So that's why the numbers in terms of failed tests don't add up with the chart below. But again, we don't see these fail very often. We do see them detected fairly often. And I'll talk a little bit more about what that actually means in terms of the detection, because there's some caveats there and some things that we need to clarify as well when we talk about detection. So if we move now to concentrates, so this is not quite as high of a number, but it's over 100,000 samples across these 10 states. You can see that the detection rate, again, is, it's about double here in this case, and the failure rate, again, about double. So, and that's to be expected. We're concentrating, so you would expect to see more of these. But you'll also notice here that that detection rate, I highlight, and I did this in the previous slide as well, but I highlight Washington and Nevada, because those are the ones where we see the highest detection rate, considerably so in Nevada, at 23%. And so there's an important distinction to be made here when it comes to this detection rate. Why is it concentrated at these two states? And if we continue on to break down by analyte, again, ochratoxin A is going to be that primary driver with just under a 0.02% in terms of accounting for 0.02% of the failure rate and the majority of the detections. But it's important to consider, are these detections even real detections? So if we actually look at the data more closely, how are these things being reported out? And you can see that that actually kind of changes over time in terms of how labs were reporting this data. So all of those detection rates, 8 of the laboratories out of the 72 total that were looked at in the context of concentrates here, those account for actually 99% of all the detections. When we actually remove these, that detection rate drops from 8.3 to now 0.12%. So that's something to consider. Are these things even real detections? Again, based on how the data is input, it's not entirely clear, but at some point reporting did change, and why they changed that, it's hard to say. Maybe for competitive reasons, people don't like to see on their COA that there is any type of mycotoxins. They'd love to see ND for all of these things. So that's a consideration, but again, it's not entirely clear what changed here. So that's something to factor in. And then if we look, and so that's 10 states, you're going to get an extra one as well for free here, and this is California. California has not provided data at present, but they did previously put out these nice reports, these weekly reports, then at the time the BCC, now DCC. And so this is looking at all matrix types, and this is over 200,000 samples, total batches that were tested at that time. And you can see the failure rate is very low. Again, in line with what we saw earlier. But again, the question remains, are we actually looking at the right toxins? So I've been thinking about this topic actually for quite a while. So this is something actually that Kevin McKernan and I were kind of considering during my time at MG, and that is, we test for these things, but do we actually see them? And so what got me thinking a bit more about this topic is that is this whole billboard, this soil to oil billboard. So you can see that this is actually from quite a while ago. You can notice the price is $169 a pound for trim and $269 a pound for moldy flour. Obviously, prices have dropped considerably since then. This is not desirable material. Now you can probably get a pound for just over that moldy flour price, depending on where you are. But again, this is a practice that was occurring. This is an actual billboard from Northern California where people are taking moldy biomass and using that to extract and serving that up as medicine later. So thought to myself, man, if people are using this in this way or doing this in this way when it comes to extraction, we might want to consider that there might be other things lurking in there. So again, there's a lot of Fusarium mycotoxins that are of potential interest. So there's these type A and type B trichothecines. They cause a host of different issues: nausea, vomiting, appetite suppression. They inhibit protein synthesis, and some of them also are endocrine disruptors. There's a bunch of different emerging mycotoxins. There are these ionophoric mycotoxins. There are also the fumonisins as well as cyclosporins. And again, these all have their own host of different effects. But these are kind of the ones that we're going to be zooming in on that are in bold. So Fusarium-Derived mycotoxins, the advisory levels for the FDA and the EU. So when we look at something like deoxynivalenol, which is one of these trichothecines, it's also known as vomitoxin for reasons, obviously causes nausea and vomiting. When we look at products for human consumption, those levels, the action level is at 1 ppm. But if we're talking about grain and grain byproducts for things like livestock, that's at about 5 to 10 ppm. So again, considerably higher than some of these other mycotoxins that we test for, but nevertheless, still levels that that may be present. 2 to 4 ppm is what we kind of ranges for the different fumonisins, and that's directly taken from the FDA's website there. And then when it comes to T2 toxin, there are no limits in the US, but the EU does regulate this at anywhere from 250 ppb to 2 ppm. And then zearalenone is another one. Zearalenone is an endocrine disruptor, so think like BPA, right? Something that basically it's got estrogenic activity. And there are no limits for this, but that is one that you'll see in a bit that we did kind of notice that was there. So the first kind of poster that was brought to my attention, this was something that was posted in my Facebook group back when Cannabis Science and Chemistry, when we prompted this question of, do we see these mycotoxins, or are we see at least the 5 that we test for, are there others? Someone pointed me in the direction of this poster by Wes McGuire, who's with Columbia Food Labs. And so they started to examine this in the state of Oregon. And so they looked at the fumonisins B1 and B2 and a handful of these type A and type B trichothecines. And he reported that 1 in 100 flower samples tested positive for Fusarium-derived mycotoxins, in particular seeing a lot of deoxynivalenol and zearalenone. I actually followed up with Wes since I saw that poster, and this is an excerpt from my book chapter, Cannabis Microbial Testing Methodologies and Considerations, that was published in 2019. And so this basically this correspondence, basically, I asked him, have you done more of this work? Are you seeing more of these? And he said that, since that poster was published, we've actually been testing a lot more extracts. And that figure is actually a lot higher. It's closer to 1 in 15 and 1 in 20 samples containing Fusarium-derived mycotoxins. And he even went as far as to say is that these are more prevalent than Aspergillus cannabis, which I found really fascinating. So I wanted to continue working on this, but of course I don't have a lab of my own, but I continued to kind of scour the literature and see what was going on. So this is another one that I found in a review paper also by Dr. Gwynn, and they looked at Fusarium mycotoxins in different CBD products in 2020, and they only looked at 10 products, but 7 out of 10 of those CBD products tested positive for Fusarium-derived mycotoxins, the max being 11 ppb. But if you think about a lot of these CBD products that are on the market, most of them are made with isolate. So, and when you think about isolates, right, there's a recrystallization that happens, right? And so when you crystallize, you push out impurities. So the idea I'm thinking here is that if these are indeed made with isolate, the fact that you are seeing 11 ppb in something that is, been crystallized like that, that must have been really heavily contaminated material to start with. And then if we look at some other kind of analytics on the samples, 60% of those samples contain zearalenone and 30% of them contain N-Antin B. 10% of the samples contain T2 toxin, which is another one that's associated with nausea and vomiting. And there was co-occurrence of these different Fusarium mycotoxins in 4 samples. Now, there's a bit of flurry of papers recently that have come out on this topic. I don't know if people just got the memo that we really need to start looking at this more closely after kind of me sort of prodding, but in general, this is from Nicole Gauthier and colleagues in Kentucky. And they sort of did like a proof of concept where they infected different hemp inflorescences with Fusarium graminearum, different strains of it. And then they examined, okay, what do we see? And this is using an LCUV method. So I want to point out those LOQs are pretty high at 3 to 6 ppm, depending on the matrix and the analyte that was tested. But those hemp inflorescences, they did find both deoxynivalenol and its 15-acetylated derivative. And these are at levels greater than 3 ppm. So again, because of those high LOQs, we also don't know if there were other things that were present maybe at lower levels that they could not see, because again, this is UV. This is not a triple quad mass spec, so the sensitivity is not going to be anywhere near what it could be. And then furthermore, Health Canada came out with a study. This is their cannabis data gathering program. So in that cannabis data gathering program, they took a look at both legal and illegal samples. What they found was in the illegal samples that they found a lot of deoxynivalenol. So that deoxynivalenol kind of ranged in values. Sometimes they were able to quantify, sometimes they were not. But they also found ochratoxin A. But again, 0.1 ppm being the highest in those illegal samples for deoxynivalenol. And then most recently, this is a paper from Max Leung and colleagues out of Arizona State University. They looked at both black and gray market cannabis samples in California and Arizona. So these were seized by law enforcement. There was 118 seized samples that they looked at. 16% of those samples contained different mycotoxins at various levels. And 2 samples had more than 1 mycotoxin. And what's important to note here is 14% of those, the vast majority of those were Fusarium-derived mycotoxins. Those are all listed here. And what's interesting as well to note here is none of those samples showed visible signs of mold growth. And they also detected kind of these different Fusarium-derived mycotoxins at various levels. Some of them are over the action levels for food. So that's something to consider that, and we smoke cannabis, we don't eat it. So route of administration is really something that we should be factoring in here. That is kind of important when we think about how these levels are chosen and what the implications may be for another route, because gas exchange in the lungs versus the oral route, again, maybe have very different outcomes. And so to kind of hit on none of the samples had visual mold growth piece. This is actually some work I did while I was at Medicinal Genomics, where we were developing a Fusarium assay. So I went out into the field in one of these grow warehouses that we knew had issues with Fusarium, and we were kind of starting to take different stem core biopsies to understand how does the actual pathophysiology of Fusarium infection work. So Fusarium, for those of you who are not aware how it works, kind of starts from, it's soil-borne, starts from the soil, and it finds a little wound. It gets into the vascular tissue and then kind of travels up the plant. And so due to the nature of how this sort of manifests, we think that, again, it's entirely possible that because it kind of goes from the inside out, that you might not see anything visually on the outside. You might see a little sad plant with Fusarium wilt. If it's Fusarium head blight, it's a little bit of a different story. You can see that visually, but again, this is something where, because of how it actually works, you may not see anything externally, but it may have a problem as well. And then I finally did get to do some work of my own on this, or at least Josh Sweeter was kind enough to run some samples after I kind of prodded him about like, hey, maybe we should take a look at this and see what we see in legal cannabis samples. So I want to point out two things. Firstly, this is actually not a fully validated method. This is all confirmed by Spike Edition, where he took a distillate sample and spiked these. So again, he doesn't have a fully validated method for this. It's sort of just kind of a scan to understand what is there and what should we be looking for. But he looked at 150 different samples of mixed matrices. I pointed him in the direction of concentrates, but he just kind of threw this on one of the batches he was analyzing. So again, all different matrix types, but there were 4 different positive hits. All the data, again, is qualitative. So again, these are all below 100 ppb, but again, we do see some zearalenone there. Again, 4 out of 150 is not insignificant. So again, an area where I think we might need to look more closely. This work is still very preliminary and ongoing. And then there's also some interesting things to note, right? These Fusarium-derived mycotoxins, especially these type A and type B trichothecenes, they have kind of a striking similarity to the actual symptoms associated with cannabinoid hyperemesis syndrome. So my personal opinion on this, as someone who kind of knows quite a bit about cannabinoid hyperemesis syndrome, we know the pathophysiology there is largely associated with things like consistent cannabis use, downregulation of TRPV1. So again, everything points to a dysfunction in the endocannabinoid system, but it's not clear. This may precipitate some of those issues, right? So something to consider. We don't have any causal evidence, but it's something we want to look at more closely. And so some conclusions, thoughts, and future directions. So more often than not, again, we don't see aflatoxins or ochratoxin A at any real considerable high failure rates in cannabis flower or concentrates across those 10 states. Cannabis flowers and cannabis products, however, do seem to contain some of these other mycotoxins, especially those derived from Fusarium. And I think that screening for these in a larger population, especially focusing in on those extracts, may reveal more contamination than expected. And then many of the concentrations that we see in the literature actually do exceed the action levels for food. And considering that inhaled route of administration, that's a potential health outcome that we kind of need to keep an eye on and better understand, because again, these are heat stable. So if you're vaping some of this stuff and it's concentrated, you might get sick. We're not entirely sure what that looks like. Also, I think just in general, policymakers need to consider, and just researchers need to consider exploring other mycotoxins associated with fungi that are commonly found in the cannabis microbiome, because that could better inform and steer policy. Because right now, I think what we're doing currently is testing for something that we just don't see. So with that, I want to give some acknowledgments by Biorad Laboratories and their food science division for allowing me to come speak on this topic. Huge shout out to Yasha Khan and kudos for all of the work he's done with the FOIA data, and he's done all the data analysis that you saw here today. Josh Sweeter, I want to thank him as well for starting to look into this further for me and running some of that LCMS data. And then I want to give a shout out also to the people who kind of inspired this presentation. Some of them I have gotten the opportunity to meet, some I have not, but they really have kind of driven my interest and curiosity in this area. And I also want to thank the Medicinal Genomics and CannMed events team for having me.